Hi students, here the chapter electromagnetic induction, class 12th physics. Very important topic. In this chapter I am going to explain the topic magnetic flux. Magnetic flux, as you have studied in previous chapters, what is magnetic field? Magnetic field is the field that develop around any magnet, and it is the closed loop as we have already studied. Now topic is magnetic flux. The number of magnetic field lines crossing normally to the surface. Number of magnetic field lines crossing normally to the surface. Suppose it is the surface plane, and it is the magnetic field lines normally strike. It is the normally means perpendicular. So it is calculated as number of magnetic field lines. Suppose this magnetic field lines, here two magnetic field lines. Now it is the surface in which 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 magnetic field lines striking on this surface perpendicularly means normally. As we know that suppose this is a plane surface, then its area vector along this direction and also in the opposite direction. If I enters here, then this direction and this direction, both directions. So here 5 magnetic field lines are coming out of the surface. As we know that the area vector of any plane surface outward in this direction and inward in opposite direction. Here 5 lines are going outward direction. Here I have indicated area vector normally for this plane. And number of magnetic field lines are 2 that are also normally to this plane. Okay students, here it is the figure A, it is B, and it is C. Here area vector is perpendicular to this plane surface. It is right, but number of magnetic field lines 1, 2 and 3. These 3 lines are not normally or perpendicular to the surface. Not this type. Here 1, 2, 3 lines are normally in this way. It is a plane surface and magnetic field lines in this way. Any angle occurs between A and B. As we know that the area vector is outwards. Suppose it is a book's page. It is a plane surface, area vector in this direction and also in this direction perpendicularly. Okay student, it is the basic concept we have to understand to know the concept of the magnetic flux. Okay students, so formula magnetic flux, it is denoted by phi b equal to b cos theta multiply a. B cos theta multiply a. Here in this figure, angle between magnetic field and area vector is 0. Theta is 0 in first case. So magnetic flux equal to B cos 0 multiply A equal to BA. Okay student, it is the first case. When angle between magnetic flux sorry when angle between magnetic field lines and area vector theta equal to 0, then magnetic flux phi b equal to BA. Then magnetic flux phi b equal to BA. Note down please. It is the first case. Now here it is the second case. In this, here as we know that we have to calculate this component of magnetic field, because magnetic field is not normal to the plane here. Here magnetic field lines are not normal to this plane. So we have to calculate the normal component of magnetic field. Here multiply A, normal component of the magnetic field. So we have considered the B cos theta. Okay students. Let theta equal to 60 degree. Then okay students, formula is this, but when we have considered for some angle theta, we have assumed 60 degree value of theta, then magnetic flux equal to 1 upon 2 BA. Then please note down this. It is the third case. When direction of the magnetic field vector is this side, and we have to calculate the magnetic flux on this side. Then here angle between B and A equal to theta equal to 180 degree. So magnetic flux equal to BA cos theta. Put the value BA cos 180 equal to minus BA. Cos 180 equal to minus 1. Okay students. So three formulas. Magnetic flux equal to BA and magnetic flux equal to BA cos theta for some values of theta except 0 and 180. Here theta equal to 0. Here theta equal to some value. And third minus BA, and theta equal to 180 degree. Okay, student, it is the concept of magnetic flux. If any doubt in this concept of the magnetic flux, then you can comment and ask any question regarding the every concept of magnetic flux. I will explain again and again. Please note down. After this, I will explain the what is the electromagnetic induction, the concept behind the electromagnetic induction, and many related topics that comes under the chapter electromagnetic induction. And I will also explain Faraday laws, two Faraday law, and Lange law, and Fleming's right hand rule. And besides this, many numericals I will explain. Okay, please note down. Students, next topic is electromagnetic induction, the phenomenon of production of induced EMF or induced current due to a change in magnetic flux linked with a closed circuit. Suppose here dotted, sorry, cross indicate that the magnetic field inside invert the plane, and PQRS is a coil that has some area A, and if PQRS coil is moved towards side, then number of magnetic field covered by the number of magnetic field lines covered by area of the PQRS coil will change, means it will increase. And if we move the PQRS coil towards left, then the area covered, then the number of magnetic field lines covered by the area of the PQRS will decrease. So first area, if change in area occurs, then the magnetic flux change. And the second is when by any method or by any manner we change the number of magnetic field lines in this area, we change the magnitude of the number of magnetic field lines, then magnetic flux change, because the formula is BA cos theta. If B change, then magnetic flux change. If A change, then magnetic flux change. Suppose if angle change between B and A, if we rotate PQRS coil this side, so angle between B and A change. If we rotate this coil, PQRS coil this side, then theta will change. In all three way, magnetic flux change, because magnetic flux formula phi equal to BA cos theta. So there are three methods to change magnetic flux. First is by changing the number of magnetic field lines, and second by changing the area of the coil, and third is by changing the theta between B and A. Okay, students, note down this please. Okay, students, now induced current or induced EMF direction. What is the direction? What will be the direction in this closed circuit of the induced EMF or induced current? It will depend on the Fleming's right hand rule. I will explain in a more clear way in my next step. I again explain this EMF induction phenomenon occurs when by three methods magnetic flux change, by changing the number of magnetic field lines, second by changing the area of the coil. If we draw PQRS towards left or towards right, then the number of magnetic field lines covered by the area of the PQRS coil change. So magnetic flux change. If we rotate this side or this side, then theta will between B and A change. So electromagnetic phenomenon induction phenomenon occurs. Okay, students, if any doubt, then you can comment. Please note down.